In this video, we're going to talk about some of the homework problems that are on your assignment sheet. Some of them are fairly complicated, and so I want to give you some helpful tips as to how you can tackle some of these problems. I really strongly recommend that you take some time to figure this out on your own first, so that you can be doing your own work. We're not going to solve all of these problems all the way through, but at least we'll spend a little bit of time. I'll go through and kind of give you the build-up, so you can get a little bit of a hint as to where to go. We'll start with question 1, and then we will also talk about questions 4, 5, and 6, and question 7. This should give you a pretty good overview of some tips and tricks of how you can deal with these things. The word problems on the back, of course, they have those videos. You may have already looked at them. You probably should. They are part of the required viewing, after all. So, question 1, we have a system. 3 halves x plus 2 fifths y equals 5, and 3x minus 2y equals negative 4. We have fractions, in other words, and we'd like to figure out, well, what do we do about the fractions? And you should deal with the fractions in the same way that you've always dealt with fractions. Find a common denominator. We only have the fractions here, so we'll only deal with the common denominator there. So we have 3 over 2x, 2 over 5y, and then just plain old 5. Now, what would help is to actually put the variable up in the numerator of each of these fractions. That will help you a little bit later on. So our denominators are 2, 5, and 1. And so, of course, we find the common denominator, which in this case would be 10. And so we're going to do, let me just move this over first. Move this over, make it a little bit bigger so you can see what's going on. I want to get all of these with a 10 in the denominator. So, over here, we'll do this in blue, over here, we got to multiply top and bottom by 10. In order to get that 10 down there in the denominator, we have to multiply the top by 10 as well. So that gives me 50. Here, I need to multiply by 2, so the top gets multiplied by 2. So I get 4y is equal to 10. That's a y there for y over 10. And then same thing here, that gets multiplied by 5, so the top gets multiplied by 5, so I have 15x over 10 there. And now do you remember what we're supposed to do now that we have the common denominator? We can get rid of the denominators. And so we get the new equation, 15x plus 4y equals 50. And then that goes along with the equation that we had before, 3x minus 2y equals negative 4. So this is our new system then. 15x plus 4y equals 50, 3x minus 2y equals negative 4, and that's the system that you can use to solve. I'm going to stop there because at that point you can take that over. You don't need my help to go any further than that. But of course, remember, we're looking for both an x and a y, so that's where we have it. We'll move on to question number 4. Because, of course, questions 2 and 3 kind of work that same way. Find a common denominator, or in the case of question number 3 there, either deal with the decimals as they are, multiply by some power of 10. Question 4 does have a bit more going on, so we're going to make this spend a little bit more time here. Alright, so we have, that's terrible. Let's try that again. That's better. So we have p minus 2 over 3 plus q minus 4 over 6 equals 1. And we have p plus 1 over 4 minus q minus 1 over 3 equals 6. Lots of fractions here. But we'll deal with this in exactly the same way as we did with any other fractions, We need to find a common denominator. So my common denominator here is going to be, bring this over again to give myself more room. For the first fraction, our first pair of fractions here, my common denominator, 3 and 6, is going to be 6. So I need to have a 6, I need to have a 6, and I need to have a 6. Of course, This one already had 6, so that doesn't change, q minus 4. The fraction here, in order to get a 6 in the denominator, we need to multiply by 2, which means we need to multiply the top by 2 as well. Here's the mistake that a lot of people make. They forget that there's parentheses. Even though they're not actually written there, they're implied. The parentheses are a part of that problem, which means that we need to distribute that 2 across that numerator. We actually have 2 times p minus 2, all up in that denominator, up in that numerator, the whole thing. And then, of course, the 1 over there turns into a 6, and the point here, then, we get 2 times quantity p minus 2, plus q minus 4, nothing happened there, equals 6. And so that gives me then 2p minus 4 plus q minus 4 equals 6. And subsequently, 2p plus q minus 8 equals 6. And then 2p plus q equals 14. So this whole business up here eventually just turns into simply 2p plus q equals 14. The same thing will work with the bottom fraction. And of course, we're going to have a 12 as our denominator, or common denominator, down there. Further thing to keep in mind, though, this is a minus. So that when we do eventually find the common denominator, we get a 12 there, we might have a minus, we get a 12 there, and we have a 12 there. Again, we'd be multiplying that by 12 in order to get the 6 to turn into that fraction. The top and bottom here get multiplied by 4, so I have 4 times quantity q minus 1. Top and bottom here get multiplied by 3, so I have 3 times quantity p plus 1. And so ultimately then I get 3 times quantity p plus 1 minus 4 times quantity q minus 1 equals 72. Pay attention to that minus sign. There was a question kind of similar to this on a previous test, and a lot of my students had a little bit of difficulty with that. I don't know if you did, but pay attention to that minus sign. Because what happens, let me scroll down just a little bit here, extend. When we distribute, we have 3p plus 3, and then we're distributing a negative 4. So we get a negative 4q, and then the negative 4 times the negative 1, that's a positive 4, equals 72. Then that gives me 3p plus negative 4q plus 7 equals 72, which in turn gives me 3p minus 4q equals 72 minus 7 is 65. So my new system then, my much more simplified system, would be 2p plus q equals 14, and 3p minus 4q equals 65. And this will be a lot easier to deal with. You can use substitution, elimination, maybe solve the top here for q. Next up, I want to talk about 5 and 6. There's similar problems to these. Questions 5 and 6. I'm actually just going to do number 5, kind of step you through that one, but since 5 and 6 are pretty much the same kind of thing, this should hopefully help you with both of them. So, number 5 here, we have 3 equations. 3a minus 5b plus 6c equals 17. Then we have b is equal to 2a plus 1, and c is equal to a plus 4. Initially, this might seem really complicated because, we have 3 equations. How can we possibly solve a system with 3 equations? But look a little closer. We're told that b is equal to 2a plus 1. And we're told that c is equal to a plus 4. Remember, when we have in our equations, in our system of equations, when we have a variable isolated like that, substitution is usually the way to go. And that's what we're going to do here. This 2a plus 1, we're going to substitute that in for b. And this a plus 4, we're going to substitute that in for c. The 3a, that doesn't go anywhere. And the minus 5, that's still the case. But now I'm saying that b can be rewritten or substituted or replaced with the 2a plus 1. And the plus 6c then becomes plus 6 times the quantity of a plus 4 equals 17. By using the substitution method, I can plug in these two expressions for b and for c. And so I end up with an equation that only has the one missing variable, only has the a that's missing. All the rest of it is just the one variable. So now I can just distribute. I distribute the negative 5 there across the 2 and the 1, distribute the 6 there across the a and the 4, and I'm trusting that you can do that part. This should be fairly straightforward once you get to this point. Question 6 is kind of the same idea. Although note, in question 6, we have that b is equal to negative 3a, and c is equal to b plus 1. So it looks like you're going to have to be a little bit more clever about how you're substituting things in.